In this lesson, we're going to start constructing our volume trails out of our points using VBDs. So one thing I want to correct from the last lesson, if you play this simulation, pause it right here, you'll notice that we have some sparseness and some negative space in our trail, and that's going to be problematic when we're trying to construct our volumes later. And the reason for this is that we're not berthing any points in the subframes of our simulation. If you remember earlier, we put down this time blend to give us subframe data on our points, and we're not taking advantage of that right now. And the reason for that is that because in our POP simulation, under the Simulation tab, we have substeps only set to 1. So I'm going to set this to 6. Go back and hit play, and you'll notice that the trails are now filling in much more. They're much more dense, and this will make our volume trails look much better. So I'm going to pause the video for right now and let this ride out. So now we have these points written out. You'll see that our trails are much more thick, and this is going to work much better for constructing our volume trails. Now to make it a little easier to dev this out, I'm just going to isolate one trail. I'm going to put down delete SOP. I'm going to look at our attributes right here, and you notice we have this source PT_num, which is the source point that our POPs replicate node is birthing off of. So we can use that attribute to isolate just one trail. So we'll do points, delete non-selected by expression, and we just want points with a source PT_num of 0. So if it equals 0, keep those points. And now we only have one trail. We'll call this ISO1 trail. Now to help us visualize things a little bit better, it'd be useful to have color mapped to some of the attributes that are on this point, these points, specifically the age attribute. So I'm going to color these points by age. So I'll come up here in our point SOP and delete channel. And I'm going to use the red and the green channel to govern other attributes we're going to create later. For the red channel, I'm going to use this to govern p-scale and then point jitter, which I'll explain in a moment. And what I'm going to set this to, so I'm going to fit the age. And if you remember, we made the maximum life expectancy of our points 10, so the age will go from 0 to 10. However, I'm just going to have it go from 0 to 6. And I'm going to have it that when the points are first born, they have a red value of 0.2, and then when they get to 6 seconds old, they have a red value of 1. And you see that go visually here. I also want to use the green channel. I'm going to use the green channel to govern density. So I'm going to fit the age again from 0 to 6. This time I want the points to be equal to 1, so they're fully dense when they're first born, and after 6 seconds I want them to start fading off. So we've got that working now. Let's go ahead and set our first attribute, which will be p-scale. Drop down our point SOP. We'll do point set p-scale. Go to particle, keep scale, and we'll just set this to CR for now. We might want to change it later, but we'll just keep it like this for the time being. Now I was talking about setting the jitter of the points, and what I meant by that is that when the points first come out of the rocket trail, we want them to be nice and tight around where they're birthing. But as the trail continues, you would imagine that the smoke would start to jitter off from the original trail. So we're going to use this jitter attribute to govern that. So I'm going to create a new attribute and call it jitter. AC jitter. The attribute name will be jitter. Local variable jitter. And it will be a vector. I'm going to make a custom parameter real quick. Drag this float over here. We're going to call it molt. And the reason for this is that we're going to use a pretty long expression to make the value of this jitter. And if we want to change the magnitude of that expression easily, it would be useful to have a channel reference that we can plug in here rather than going into each of these and changing what they're multiplying by. So just something to make it a little bit easier to change if we want to change how this looks later. So the expression that I'm going to want to put in here is a fit function. I'm going to fit the red channel from 0.3 to 1 to the value of 0. So we want it that when the red channel is 0.3, we don't want any jitter on it. But once we get to a red value of 1, which is the back of the trail, we want full jitter. And to get a randomized value for our jitter, I'm going to put another fit expression in here and base it off of rand ID. Now rand ID, or any rand, is always going to return a value between 0 and 1. So we'll have between 0 and 1. And a good magnitude for something like this is -10 to 10. And again, we put down that molt, so I'm going to multiply this by a channel reference to molt. So I can very quickly increase or decrease this in case I want to increase or decrease the overall value of our jitter. I'm going to copy paste this into these other channels, but I'm going to want to change one thing like we did earlier. We want a different seed for our ID. So I'm just going to multiply this by an arbitrary value so they're not all equal to the exact same thing. Now to actually get this jitter to show up, I'm going to drop down another point SOP and just add the position to the jitter. Point add jitter. So we notice what this is doing. We're going to add $tx to jitter x, plus jitter x, $ty, jitter y, and $tz to $jitter z. And as you can see, towards the back of our trail, we're starting to get the points more broken up. And if you see here, I can move this molt so we don't want any jitter or if we want a lot of jitter. Now that's probably too much, so let's keep the molt to 1. And then finally, I want to make one more attribute for density. And we're just going to set this purely to green. Density, and it will be equal $CG. So now we have our points set up. Let's go ahead, whoops, sorry, I didn't mean to lock that. Let's go ahead and actually use the VBD tools to construct our volume. So to do this is also new in Houdini 13, we have this new cloud SOP. So I'm going to drop that down and wire this in. First thing we're going to want to do is change this to a point cloud model. We're also going to want to do our division size by size. Now to make it a little bit more interactive, I'm going to set the division size to 0.3. I'm also going to increase the P scale just slightly to 1.3. I'll come over to the density tab, and the density multiplier is a little bit too much, so I'm going to just set that down to 5. And then everything else over here we should probably leave as a default. Now you'll notice in our trail over here we're getting volume, but it's very, very sparse. And one way we can fix that, remember earlier we put that point set to P scale, so the P scale of these points is based off of this P scale attribute, so we'll probably want to increase this. Let's multiply it by 3. And that gives us a much more reasonable trail. Now if we wanted to bias the P scale based on the color in any way, we can use some POW expression. Maybe do $CR to the 1.4. I should have had the cloud displayed. So I'll just go ahead and change this back. So by putting this expression in here, if you watch the cloud, we've now thinned out the trail a little bit more towards where the rocket is. We don't want the smoke to be too thick when it comes out of the rocket, because if it's too thick it will be bigger than the rocket and will look kind of odd. But for the initial setup for our trail, this will work pretty nicely. So that's how we construct the volume trail with Cloud VBD modeling tools. In the next lesson we'll start adding some noise to the trail to make a more interesting volume shape.